Okay, let's go ahead and start tonight's homework over section 3-4. So here we go. We are going to isolate the log of base 10. So we're going to divide both sides by 4. So this is log base 10 of x minus 6 is equal to 11/4. Now, how do I solve this? That's 10 to the 11/4 is equal to x minus 6. All we do is write that as an exponential. This 10 to the 11/4 is just a number. So I'm going to add 6 to this just a number. And then I'm going to simply come over to my calculator and type that in. 10 raised to 11 divided by 4 plus 6. And hit enter, and you're going to get 568.341. And then that is done. Okay? Next, number 5. Now, there's a lot going on here. So I'm going to go ahead and I'm going to take this and divide it by 20. Okay? So I have 100 minus e to the x over 2 is equal to 50 divided by 2. Mark off the zeros. 50 divided by 2 is 25. Isn't that a lot easier than distributing, right? Super easy. I noticed that it ended in 0, so that's why I divided by 20. Numerical number sense, okay? So now we're going to go ahead and isolate this e. So how do I do that? I'm going to subtract 100. So negative e to the x over 2 is equal to negative 75. From there, you're going to divide both sides by negative 1. E to the x over 2 is equal to 75. Now, this is an e. E is a base of 2.718, yes? So all I'm going to do is I'm going to simply take the natural log of both sides. The natural log and the e cancel out, and I'm left with x over 2 is equal to the natural log of 75. This natural log of 75 is just a number. I'm going to take that number calculation, and I'm then going to multiply it by 2. So I'm going to have 2 times the natural log of 75. So you come back over to your calculator and you type that in. 2 times the natural log of 75 and hit enter. Gives you 8.635 because the 9 makes that 4 round up. So I come back over here and I'm going to write x is equal to 8.635. Okay? Let's keep going and do number 6 for you. Number 6. Okay, now here's what your brain needs to see. I have more than 2 natural logs. On the left-hand side, I only have 1 natural log, but on the right-hand side, I have 2 natural logs. So I am going to condense this, writing this as 1 natural log like we did in section 3-3. That means the natural log of x plus 5 is now equal to, in log world, subtraction. Subtraction is the same thing as division. So that's x minus 1 over x plus 1. Now, I have a logarithm equal to a logarithm, and they have exactly the same base. Since they have exactly the same base, I can cancel out the logarithms, and I can have x plus 5 is equal to x minus 1 over x plus 1. Well, that's interesting, because now I'm going to make this into a fraction equaling a fraction, and I am simply going to cross multiply. X plus 5 times x plus 1 is equal to x minus 1. Okay, so I see 2 binomials attached by multiplication, so I need to FOIL. X squared plus 5x plus x plus 5 is equal to x minus 1. I'm then going to combine like terms. X squared plus 6x plus 5 is equal to x minus 1. I then is going to bring over this x by subtracting and adding the 1. I'm doing that in one step. It's totally fair. To give you an x squared plus a 5x plus a 6 is equal to 0. Now, how do I factor that? Well, that is going to give me x plus 2, x plus 3 is equal to 0, x plus 2 is equal to 0, x plus 3 is equal to 0, x is equal to -2, and x is equal to -3. Now, just like we have always done, if you look at this entire problem, your brain should be saying, whoa, I have 2 negative answers. Is it possible for me to ever have an extraneous solution? Remember, extraneous solutions are solutions that appear to algebraically work out, but whenever you plug them back in numerically, it doesn't make any sense. You get a false answer. So here's what I need your brain to understand. If I were to plug in a -2 here, I'd have the natural log of -2 plus 5 is equal to the natural log of -2 minus 1 minus the natural log of -2 plus 1. And my board's getting smaller and smaller to see here. So the natural log of 3, well, that seems possible. I'm okay with that. And this is the natural log of -3. What number, e raised to what power, is going to give me -3? Your brain should be sitting here saying, can I take and have a -3 as my x values? Well, let's go ahead and look at the natural log of x graph. There's an asymptote here, meaning my domain of -3, my answer is not in there. -2, -3, anything below 0 is not part of the natural log function. Meaning, these 2 answers, this right here, man, that's not possible. That means this isn't possible and this isn't possible, so the answer is no solution. -2 and -3, when you plug them back in, are not part of the domain of the natural log function. The natural log function only exists for the values for x being greater than 0. Value of -2 and -3, you cannot take the natural log of -2. Let me show you. The natural log of -2, non-real calculation. It's not part of the domain, so it's not possible, okay? So that's why number 6 is different. Number 13. Number 13, we're going to go ahead and do this. This looks super difficult, but it's really not. And the reason why is because I have 3 different bases. As soon as you see you have 3 different bases, your brain should be saying, okay, can I make them all be the same base? You absolutely can. 81 is 3 to the 4th. 243, well, that's 81 times 3. So this is 3 to the 4th, so that means that's going to be 3 to the 5th. Okay? All right, well, let's keep going with our rules of exponents. I'm going to multiply those, so that's 3 to the 4 times 3x plus 2 over 3 to the -5x is equal to 3 to the 4th. Okay, well, if I keep doing my rules of exponents, I have a base with the same base underneath of it, and they're being attached by division, so that means I'm going to subtract those exponents. So if I subtract those exponents, that's 3 to the 4 of 3x plus 2 minus a -5x is equal to 3 to the 4th. Well, now I can cancel out those bases and simply set the exponents equal. So 4 to the 3x plus 2, or times, plus a 5x is equal to 4. And you simply solve this. 12x plus 8 plus 5x equals 4. 17x plus 8 is equal to 4. 17x is equal to -4. X is equal to -4/17. Now, are you asking, am I able to do this problem? Is it in my domain? Well, the exponential function, this is so annoying to me. looks like this, which means x is an element of the reals, there's no domain restrictions there. There's only range restrictions, which means this answer is totally okay, and you are able to do that without any problems. Okay? If you want to give this to me as a decimal, that's going to be the same thing as negative 0.235. Okay? And the last problem I'm going to do with you is going to be problem number 14. And this one is the trinomial problem that you basically just want to factor. How do I split up e to the 2x evenly? That's e to the x here and e to the x here. I need factors of 6. That's going to be a 1 and a 6 or a 2 and a 3 that will subtract. Not subtract, sorry. I need a positive 6, so that means my signs are the same, so I need to add them. So I have to use 2 and 3, but I need them both to be negative. So e to the x minus 2 is equal to 0, e to the x minus 3 is equal to 0, e to the x is equal to 2, e to the x is equal to 3. So now, how do I solve e to the x? I have to get rid of the base of e. The only way I can do that is by taking the natural log of both sides. So x is equal to the natural log of 2. Same thing over here. So x is equal to the natural log of 3. What numerical value are those? Sorry. The natural log of 2, the natural log of 3. That's what you are going to have. Those are your two decimals that would be equivalent, okay? That is tonight's homework. If you have any questions, please let me know. Make sure you check your answers on the answer key that I post. Make sure that you are getting rid of the base that you have if you have an exponential by taking the logarithm of both sides using that base. And if you have any questions, please let me know.